Nice to meet you. I'm Daniele Giunta. I'm an AI engineer at Terris Innovation Hub. And this is not my really first talk. I already held some other talks about AutoGen and how multi-agent systems can interact together to solve complex tasks at PyData Roma Capitale. And today I want to present you this new hot topic that is exactly how to fine-tune a LLM locally, showing you a practical example. So briefly, this is the roadmap that we're going to follow. So we will answer a question about why we're talking about fine-tuning large language models. We will define briefly what is fine-tuning, what do we intend for fine-tuning. Then we will move from theory to practice, and we will finish our lecture by providing some key takeaways. So firstly, why do we talk about large language models? Why do we want to use them locally? Well, the main reasons are in order to overcome what the main limits of cloud-based LLMs are. So firstly, they regard about privacy. So with local LLMs, data stays in our hands. They never leaves our laptop, our environment, our machine. Secondly, customization. We can customize our model. We can adapt our model with respect to our company data, company needs, our domain. And finally, in order to overcome cost and speed, since with local LLM, we don't have to pay any fees for API calls, and since the data and queries does not travel over servers, the response times are really faster than with the cloud-based LLMs. So what is fine-tuning? So let's think about, for example, if I ask to a cloud-based LLM, what can I do, what should I do in order to change, for example, my company laptop? Well, probably it will start by providing us a list of steps that we have to do in order to request for a new laptop. Like, for example, understand which part of your laptop is broken, and probably you have to ask for permission to your manager, then you have to write to the HR, and so on. But what if our company has specific policies? So we need to follow some specific rules in order to request for a new laptop. Well, this is where fine-tuning comes to help us. How do we do this? Well, we take a pre-trained large language model, and we train it further. Further on what? Further on our specific data. Okay. For sure, we can use a common technique used, supervised learning, for which we provide input-output pairs. So, for example, question and desired answers. So a concrete example may be the one of creating a customer support chatbot for a retail company. So in this case, we will teach our model how, for example, we will provide some logs between the end user and how our employee would answer to these issues, such that in the end, our chatbot will behave as our best employee would do. So in the end, it is about to make the model expert in our specific context. So with this brief introduction, we can move on from theory to practice. And here is a list of some tools and services that we are going to use. In particular, we are going to use Jupyter Notebook for fast coding prototyping. Then we will use Jupyter Notebook inside Google Colab, since we'll borrow some GPUs from Google. And finally, we will fine-tune Meta's Llama 3.2 model. We will use also Unsloth, that is a cool Python package that is really good for efficient fine-tuning. And it is well compatible with the huge ecosystem of Hugging Face. And finally, we will use this tool, this service known as Anything LLM. We will use it to connect our fine-tuned LLM model to a user interface. So now we move to our Jupyter Notebook. So in this first cell, I've already installed for you these packages. Since we're running it on Google Colab, we have to install other dependencies and so on. And I've already done it for the use case. Here we are downloading the Llama model. In particular, we are downloading the 3.2 instruct model with 3 billion parameters. 3 billion simply because it is a good trade-off between the weight of the model and the efficiency. So here there are some other parameters. We'll see also later on some other parameters. I will not dive into too much details for the purpose of this lecture. So since it took some time, I already executed these two cells. And now we're going to add what is called as LoRa adapters, also known as low-rank adaptation of large language models. And if you, in simple words, it lets our model to be fine-tuned, to be trained not on all of the 3 billion parameters, but just over a few of them, like from 1 to 10% of all the parameters. This is the initialization of the model. We are using the getPFD model function that stands for parameter efficient fine-tuning in order to adapt to use the LoRa technique. Here I'm using some parameters value that was set by default, and that they are set because of efficiency for this model. So firstly, we run this cell to initialize this model. And in the next cell, we're doing the same thing, but we call it in a different way, because in the end, we're going to fine-tune this particular instance, and we will see some differences between what happens before and after the fine-tuning. So once this cell is done, here we're going to test the base Llama model. So in this case, we are going to ask a simple question, like what is Fibonacci series? Now it's taking really much time, but it's not a problem because we have already the output for us. So here, as we may expect, the LLM, the meta model, will answer with a long text explaining what is a Fibonacci series. So Fibonacci series is a series of numbers in which each number is the sum of the two preceding numbers, and so on. But what happens, as we were saying at the beginning, if we ask to request for a new company laptop? Well, in this case, as we already said at the beginning, it answers by providing us a step-by-step guiding on how to do this kind of task. So before you request, check company policies, review your company's IT department or HR policies. Requesting for a new laptop, you have to schedule a meeting with your supervisor or IT representative. It also provides us an example of email that we should write to our HR mail, and so on. So, but what happens if, as I was saying before, if our company has specific policies that needs to be followed? This is what we're going to do from now on. So here we're going to upload a simple data set in JSON line format. And I'll let you show it with convert it to pandas data frame just to show it. So as you can see, is a simple question answer. There are two fields, that question and answer. We can read some of them, like, for example, where can I find the forms for travel expense reporting with their corresponding answer, what approves leave request longer than 10 days with their corresponding answer, and so on. So at this point, we have to format this kind of data set. We have to add the role. So we have to convert it in role, user, and role assistant format. This is what is done in this cell, and this is the output. So as you can see, it has been converted to a list or list of dictionaries containing for each role and for each question the corresponding role and content. So we have for role user the question, how do I request a new company laptop? As a role of assistant, the corresponding answer. But this is not enough, because we have to further modify this data structure. In fact, we have to adapt it such that, in the same way that the llama model was trained at the beginning. So we have to add these tags that we'll see after running this cell. So this is before the application of this formatting procedure. And this is how the new structure results. So it has been converted in a single string with some tags that identify where, for example, the text start and the end for both user and assistant. At this point, we can use the Hugging Face TRL's SFTT trainer. So that is, TRL stands for Transformer Reinforcement Learning, and SFT stands for Supervised Fine-Tuning. So TRL is a cutting-edge library that is really used for post-training foundation models. And of course, it can be used with the supervised fine-tuning. So with this cell, we're going to do this stuff. So we are putting all together in the SFT trainer by selecting the model we want to fine-tune, the corresponding tokenizer, which is the data set, which is the field that we want to use to train our model, and some other parameters that have been set by default to make the training faster and more efficient. So after running this cell, probably this cell wasn't run before, but we can go on. Okay. Probably a cell before wasn't run correctly, but we can go on. I'll explain you. There is no problem. So here, with this cell, we can see some statistics about memory usage. So it's been using a GPU with a Tesla T4 with 15 gigabytes of memory. Just half of it will be used to train the model. At this point, we can train our model not in order to let it understand both question and answer, but we will let it focus only on the answer part. Why? Because we want our model to understand the context, so all the policies that are inside our company policies, and also in order to let it understand the style and the tone of the answer. And this is what is done with this train on response only function. So, like during the training, the loss will be computed only for the response part, while the instruction part will be masked. At this point, the training can start by this simple call to train function. And here there are some statistics. For example, it says that Onslaught make the fine-tuning 2 times faster. There is 1 GPU used. Our data is composed of 100 number of examples. Just for a matter of time, we train our model just for 40 steps. And here we can read that among all the around 3 billion parameters of our model, less than 1% will be trained. So I already ran this cell, and as you can see, the loss value starts decreasing. So starting from around a value of 4, it decreases over time, reaching around almost the value of 1 after around 40 steps. So at this point, we can test our fine-tuned model. And we can test either by running this cell or in another way. So I'm going to show you the second way. I think is way cooler than this one. But firstly, Onslaught let us export our fine-tuned model by using this function. So with this function, we're going to export the model in a format that is readable and compatible with some runner for a large language model, like Llama 1. So I already done this for you, since it took a lot of time. And at this point, we have 2 things that we can do. either start creating the model by running it over Llama and using the command prompt in order to ask questions. Otherwise, as I was saying at the beginning, we can use anything LLM. So with anything LLM, we can use it as a user interface, like, for example, the ChatGPT one. And what we have to do is to go to Settings, selecting as provider the Llama runner. It will automatically detect the large language model that have been already created. And after that, we can directly test it. So, for example, here we can ask, what should I do if I want to request for a new laptop? Now, if everything works, it will answer with respect to our company's policies, and it will not provide the long answer that we have seen before. So probably it's a bit slow because, okay, it is answering. So what we have to do, we have to fill out the IT asset request form on the internet and send it to the asset.it@fintazienda.com. We can ask for other questions like, what do I have to do if I mail? Well, I have to notify my manager and send a doctor's note via email within 3 days. Another example, maybe for example, what should I do if I want to change project team for some reason? And again, we have to send a request to the project manager and send an update to the HR manager. So probably we can read that our model understood and learned not only the context of our company, but also the style and tone of the responses based on the dataset that we provided to the LLM. So moving back to the slides, we are almost done. Here there are some takeaways. So many months ago, thinking about fine-tuning a large language model was something that it was thought to be only for big companies because of resources that they had. But for sure now, with all these tools that are available for us, like the one we have seen today, like Unslot plus the Hugging Face ecosystem, it has been made more practical and accessible to all of us. In the end, as we have said at the beginning, fine-tuning large language model locally it is great for privacy, customization, and control of our data. But if you think about it, previously I used a dataset. It was simply composed of question-answer pairs. So it was a really well-structured data, and it was really cleaned. Of course, it was a synthetic data, and it was already prepared for this lecture. But unfortunately, this is not what happens in real life. In fact, most of the times, our data are sparse in our company sources that can go from SharePoint sites, Google Drive, emails, and so on. So in my opinion, the hardest thing to do in order to have a good model fine-tuned is to have a good way to collect all of the data that is needed in your use case and make them really clear. So it is the part in which, in my opinion, we should all take our energy and effort on. To conclude, in my opinion, it is better to have a shorter dataset that is well-formed, well-structured, and cleaned very well, rather than having a huge data set, but that it is completely messy. So this is the end. Thank you.
Thank you so much. Okay, we do have a few questions on Slido, so I don't know if I can ask all of them, but let's try. So the first one is regarding customization. Current language models, large language models, seem to have good results via different techniques like RAG or instructed prompts. Could you provide use cases where fine-tuning is the to-go option over more simple techniques?
Okay, that's an interesting question. Maybe I can use one slide that I, let's say, prepared to solve kind of similar questions. So, because this is kind of frequently asked question, no? When to use fine-tuning, when to use RAG. So, talking about fine-tuning, the model learns new info and stores it internally. When you fine-tune a model, there is no need to have constantly updated data. So it's something that is static. So you have data, you fine-tune your model, and that's it. And the power also of this fine-tuning is that the model can also reproduce the style and tone of the answer. But talking about the RAG, or retrieval augmented generation, that is kind of, mostly used in most of the use cases. For RAG, the model looks up information from external sources, from external documents, in real time. So probably I will answer this question by reading this line again. It is well suited for scenarios that needs up-to-date information. So in scenarios in which data changes frequently, and also the end user needs to have up-to-date information. And most of the time, the data used is document-based. So in my opinion, if you want to have a use case in which, if you have a use case that needs up-to-date information, probably the RAG is the best solution. But in general, when we want to know if it is better to use fine-tuning or RAG for a specific use case, I would like to answer this question with the same answer that most of the engineers would say. I don't know if you know it, but it depends. It depends on the use case, of course. So I hope that with this slide I clarified.
Yeah, I think so. This kind of answered another question that was, how do you maintain your fine-tuned model? And how expensive is the maintenance to keeping up with up-to-date data?
Okay, well, I was just said, maintaining a fine-tuned model is quite time-consuming because I was said once you have trained your model, you have it. So if you want, for example, some data that are available inside, for example, your company, you need to do again the training and the fine-tuning of your LLM. So in this case, it's also better to understand if it's better to use a fine-tuned model or another kind of technique.
Makes sense. Okay, then we have, I often have problems to fine-tune my LLM with data behaving to a relational database. Do you have some tricks about that?
Data about relational data. Probably, I don't know the specific use case, but maybe you may think to, let's say, move your data from the database to a new different source that maybe, for example, can handle better the data that then you need to provide to the fine-tuned model. Now, on my feet, I don't have a specific recommendation for this task, but we can, if you want, we can reason together later on.
Okay, then we have a few questions. So let's go with this one. In a multimodal fine-tuning, that's kind of hard to answer, but what are the best practices?
Well, let's say that it goes a bit out of my knowledge in terms that I liked the fine-tuning of the simple, the classical fine-tuning with just text. Probably the hardest part in using multimodal model will be, again, in my opinion, the part of related to the dataset. So to build the dataset, because in that case we do not have only text, but we have to manage also images. So probably there would be a way to manage both of them together and to have a fine-tuned model that really fits your needs.
Okay, we have some more like easiest question. Some of them you already answered, so I won't say them. They are asking if your code is published somewhere, they can find it.
Not at the moment, but I'm going to push it on my GitHub.
Okay.
So if there is a possibility to share then the Git, I will share it with no problems, of course.
Okay, I think we have time for one more. I think so. How do you handle the model in production? Do you keep a machine always running, or do you could start it only when a new requests come in?
Well, in production, what we can do is moving for sure from Google Colab and Jupyter Notebooks to something that is more reliable. So one may think to move from local to Azure. So there is all the Azure ecosystem that is really good to do this kind of stuff. So there is Azure Machine Learning Workspace that provides you some GPUs. And in this case, you can also set, for example, some virtual private network. In that way, your data never leaves your company network. And you may also set for example, your virtual machine to be powered just for some period of time, the needed time that the application needs to run.
Okay, I think we have time for one last question. Okay, you use a tabular dataset, like with question answer to fine-tune the model. How can one build such dataset if we start with company documentations? I don't know exactly what's the...
if I understand the question, so if we start from like a PDF document in which there are a lot of company policies, we can do things. Either we employ some people that are in charge of creating such datasets, so they could do manually question-answer pairs related to our company policies, or otherwise we may use some large language model, so either local or some cloud-based. So starting from this PDF, please generate 100 of example of question-answer pairs that are needed to fine-tune my local model. Yeah, this is something that can be done for sure.
Okay, I think we don't have any time left, so thank you again.
Thank you very much.